We are raising a $40 million Series A to scale the Ukiah Gigaline manufacturing facility for HYG TP200, a biodazed graphene thermal spreader. This hard asset infrastructure play targets $61 million in monthly recurring revenue by reclaiming $20.8 billion in value currently lost to thermodynamic inefficiency. For operators, the payback period is less than 1 week of operation. Next-generation AI accelerators, like the NVIDIA Blackwell, operate at extreme power densities exceeding 1,000 watts per chip. This pushes the semiconductor industry against a hard thermodynamic limit, known as the thermal wall. Traditional copper cooling systems cannot wick heat away from the silicon die fast enough. To prevent catastrophic burnout, the firmware forces the hardware to throttle, reducing performance by up to 30%. A mere 10% thermal throttle on a single $3.2 million hardware Mac creates a direct loss of $320,000 in realized annual value. Excessive heat creates a cooling tax that directly erodes the marched value of deployed capital. The intervention is HYG TP200. It is a drop-in replacement material synthesized entirely from zero-cost agricultural waste using flash Joule heating. This process engineers a thermal spreader that operates at over 1,500 watts per meter Kelvin, nearly 4 times the thermal conductivity of copper at 1/4 of the weight. By instantaneously capturing 98% of the thermal energy directly at the die level, this material eliminates thermal throttling. Multi-million-dollar AI racks can now run continuously at 100% compute capacity. Significantly lighter graphene architecture reduces mechanical shear stress on delicate BGA solder joints, extending GPU operational life by 24 to 36 months. For hyperscalers managing $40,000 chips, this 3-year functional extension reduces annualized replacement capital expenditures by 40%. HYG serves as compute insurance, securing a combined $20.86 billion in total annual benefit across OpEx savings and compute recovery for the top 10 U.S. operators. This chart details the grid power recovery metrics. By compressing a facility's power usage effectiveness from an industry average of 1.58 down to 1.08, HYG TP200 returns 4.89 gigawatts directly to the national grid. Looking at this cross-section diagram, the higher thermal tolerance of the material allows hyperscalers to transition to 100% liquid-to-air dry cooling. This eliminates 42 billion gallons of evaporative water waste annually. Establishing thermodynamic sovereignty at the chip level transforms the data center from a grid liability into a stabilizing, restorative infrastructure asset. The transition away from legacy copper cooling is dictated by thermodynamics. With $417 unit margins and a 40-day CapEx payback period, and today our manufacturing line is fully scaled to meet pre-sold hyperscaler demand. Deploying this $40 million Series A will fully capitalize the Vineyard to Blackwell manufacturing pipeline and permanently close the AI thermal gap.